So, again, this is the last chapter in the course. We're going to spend a couple more days on this. Friday, we're going to have a quiz on this chapter. Monday, we'll go through that quiz and probably the chapter 2 quiz as well, because Tuesday will be your last unit exam. So that's happening Tuesday, a week from today, your last unit exam. And also, your final exam in this course will be Monday, June 19th. So that's a different day than what will be on the exam schedule when it comes out. And the reason for that is I'm gone the last week in June to mark diploma exams. I'll be in Edmonton. So I have to schedule our exam a few days early. Then the rest of the 10Cs will be writing theirs. So I'll be sending out several emails to both your parents and you, reminding you of this, that your final exam is on Monday, June 19th, and that's a day where grade 10s have no exam scheduled. It's during exam week, but there's no exam scheduled for grade 10s that day. So that's why that day was selected. Monday, June 19th at 8:30 in the morning. Yes, everything in the course. Yep. So again, we're going to be writing our last unit exam next Tuesday, a week from today. So that means starting on the Wednesday, we're going to be reviewing. So we're going to have about a week and a half of review, or maybe should be about 6 days in class to review. So as we get down to crunch time, attendance becomes a little more critical because we're going to be learning some new stuff this week and we're going to be doing review for the final exam. So you want to make sure that you're here to class every day, right? Because each day you're here for review, it's going to help you for the final exam. Also remember that Friday, June 9th, so that's a little more than a week away, is the last day for you to hand any of your missing assignments in. After that, they go into zeros, your marks will go down. No excuses, no extensions. You guys have had lots of warning about this already, right? So if you left things too late and then something happens and you don't have time to work on those assignments, that's on you. No extensions. Okay? So that day is actually a PD day. You guys don't have school, but I'll be here and you can email me your assignments. You can take a picture of it and you can send it in an email and I'll get it and I'll mark it. I'll print them off and mark them. Okay? So again, it's important this last week and a bit that you're here every day, that you're doing the assignments, that you're doing the practice, and you're studying for quizzes. This is not a time to be slacking off. I know that the semester is almost over, the school year is almost over, it's getting nicer outside. Sometimes it's harder to focus, but you need to find some way to do that, right? Because we're continuing on, and if you don't prepare for stuff, then you're not going to do well. Okay, so yesterday we saw that we have these trigonometric ratios, and they are used for right triangles. We saw that we can label the sides of a right triangle. The hypotenuse is always the side across from the right angle. That never changes. But the opposite and the adjacent side do change. They are labeled according to what angle you're using. So because this angle is labeled as theta, that would tell us that that would be the angle that we would use. The side across from that is the opposite. The third side is the adjacent. We're going to do this process almost every time we see a question involving right triangles. The only time we wouldn't is if you've got two sides of a right triangle and you want to find the third. That's Pythagorean theorem. And we've done that before, and we'll see some more examples this week of that. But this is how we normally start. And then we have our three trigonometric ratios. The sine of an angle theta is equal to the length of the side opposite theta divided by the hypotenuse. The cosine of an angle theta is equal to the ratio of the side adjacent to theta divided by the length of the hypotenuse. And the tangent of an angle theta is equal to the length of the side opposite theta divided by the length of the adjacent side. So these are the three trig ratios, and they are on your formula sheet, so you don't have to memorize them. They are there for you, but you have to know how to use them. And you use them to find missing sides and missing angles in right triangles. So for these examples, it says find x or y in the following triangles, round to the nearest tenth, which is 1 decimal. So looking at the first one, we want to find the measure of x, the height of this triangle. That's what we're looking for. Our first step is to label the sides. The side across from the right angle is always the hypotenuse. That never changes. Because we're given this angle of 33 degrees, we're going to use it. So the side across from that is the opposite. The third side is the adjacent. This will always be our first step. The only difference between this and what we looked at yesterday is yesterday in most cases we just had the angle labeled with a letter or a Greek symbol. Here the angle is actually given as the number of degrees, but it doesn't change the way we label the sides of the triangle. So this part is nothing new. We've done this, we did this yesterday. So here's the next piece that you need to remember is you need to find out what x is. If you look at what you are given and what you're trying to find, specifically the sides, we're given that 6.5 side, which is the adjacent. We want to find x, which is the opposite. So I'm going to kind of group them together. We are going to use the opposite and the adjacent in this case because we want to find the opposite and we're given the adjacent. And if you look above, you'll see that the ratio that uses opposite and adjacent is the tan. That is the only ratio that uses both the opposite and the adjacent. Sine uses opposite, but not the adjacent. Cosine uses adjacent, but not the opposite. The only ratio that uses opposite and adjacent is the tan. So we must use the tan theta in this case. Again, because we want to find x, which is the opposite. We're given 6.5, which is the adjacent. That's how we know we must use opposite and adjacent. And so now we'll write our equation, the tangent of the angle. So again, we're used to writing the angle as theta or some letter. But in this case, we're told what the angle is. The tangent of 33 degrees equals. And again, the definition above tells us that tangent is the opposite, which is x, divided by the adjacent, which is 6.5. They must be in this order because the definition of tangent is opposite over adjacent. It's written above. It's on your formula sheet. Tangent is opposite over adjacent. So now we need to find out what x is. We need to solve for x. So what I normally do here, because the right side is a fraction, I make the left side a fraction as well by putting it over 1. You can divide anything by 1, it doesn't change it. And now I will cross multiply. When two ratios are equal, their cross products are equal. So 1 times x, I'm always going to start with the pair that has the variable. 1 times x, which is x, will equal 6.5 times the tan of 33 degrees. When you cross multiply, that's what you get. And it is kind of important that you start with the 6.5 first, and we'll talk about why in a second, which is why I wrote it in that order, because you could go tan of 33 times 6.5 as well, but I'm going to show you on the calculator why you need to be careful if you do it that way. So we go to the calculator, and we talked about this yesterday. If you're doing questions involving trig ratios, your calculator has to be in the degree mode. And so these TI calculators, they default to radians. So every time they're reset, they go back to radians. So you always want to check to make sure you're in the right mode, degrees. And we went through this yesterday. I told you how you can change the mode on your calculator. There's a couple different things that you might need to look for. Yesterday, everyone seemed to work for them, so I'm assuming you know how to do that. So now I'm in the proper mode, and I'll go 6.5, 6.5 times the tangent of 33 degrees. Enter. You should get an answer of 4.2. That is the answer. That's what x equals. That's the length of that missing side. And because we're rounding it, I'll use approximately equal to. And because the adjacent side is in feet, the opposite would be in feet as well. If you didn't get that number, then you're not using your calculator properly. Everyone got that when you did it? You're in reading mode. You got to be in degree mode. So you hit this mode button here, there, and then you go down to degrees, like that. And now it works. So now if you do the same thing again. All right. So I said you could do the tan of 33 first, but notice that when you hit tangent, a bracket opens. If you just put 33 in there and then go times 6.5, you won't get the right answer. Because what the calculator did, it multiplied 33 by 6.5 first, and then took the tangent of that number. If you're going to do it in that order, you have to close the bracket after the 33. You're taking the tangent of just 33 degrees. So you have to close the bracket after that, and then multiply by 6.5, and you get the same answer that way. Right? So, just something to be careful about. All right, looking at question B. We start by labeling the sides of the triangle. The side across from the angle is the hypotenuse, that never changes. Because you're given angle B to be 28 degrees, you're going to use that in the problem. The side across from that is the opposite. The third side is the adjacent side. So look and see what you're trying to find and what you're given. You're given the 31.5, so we're going to use that. You're also trying to find x, the opposite side. You're given the hypotenuse, you want to find the opposite. So I'm going to group those together. And if you look above, you'll see which ratio uses opposite and hypotenuse. Which ratio, Brock? You have sin on the brain? You have sin on the brain? Are you a sinner? Huh? I think you might be. So that the abbreviation is sin, but it means sine, right? So yes, you will use the sine ratio here. That's the only ratio that uses opposite and hypotenuse. And the order matters. It tells you what order they have to go in. But instead of using the sine of theta or the sine of B, we actually know what the measure of that angle is. It's 28 degrees. So the sine of 28 degrees will equal, and again, the order matters. The definition tells you that sine is opposite over hypotenuse. Opposite on top, hypotenuse on the bottom. They must be in that order. So we want to find out what x is. Like we did in the previous question, because the right side is a fraction, I'll make the left side a fraction as well. And then I will cross multiply. Whenever two ratios are equal, their cross products are equal as well. So 1 times x will equal 31.5 times the sine of 28 degrees, which is what you're going to put in your calculator. What do you get when you do that, Keen? What do you get when you do that? Do it on your calculator. Oh, I got So you went 31.5 times sine of 28, 14.8. Is that what you said? And because the hypotenuse is in centimeters, yes, this will be in centimeters as well. So I talked about this yesterday. Surveyors use trigonometry all the time in their work to be able to find the height of something or the width of, let's say, a river that they can't physically drag a tape measure across, right? So they use it all the time. Okay, so for this next one, I want you to start by labeling the three sides of the triangle. Look and see what angle you're given. Look and see what side you're given and what you're trying to find. So you're going to label the three sides and then figure out what ratio you need to use. So the side across from the right angle is always the hypotenuse. That never changes. Because you're given the angle P to be 44 degrees, you're going to use that. The side across from that is the opposite. The third side is the adjacent side. In this case here, you need to use the adjacent and the hypotenuse. Brooklyn, what ratio uses the adjacent and the hypotenuse? Look on the previous page. You'll see the three trig ratios. Cosine. That's right. So you need to write your equation. And again, you have to pay attention to the order that the ratio is written in. The definition of cosine is that it's adjacent over hypotenuse. Adjacent first, hypotenuse second. Adjacent on top over hypotenuse on the bottom. This one's a little different than the last two we did because the last two we did, the variable was on the bottom. If we back up and have a look, in each case, the variable was on the top. The variable was on the top. So when you cross multiplied, you had the variable by itself. In this case, the variable is on the bottom. So when we cross multiply, it will not be by itself. So let's see what that looks like. When you cross multiply, and again, I'm going to start with the pair that has the variable in it. It'll be y times the cosine of 44 degrees equals 10.2. In this case, we have to do one extra step because after cross multiplying, we don't have y by itself. So we will have to now divide both sides by cosine of 44 degrees to get y by itself. So on the left, the cos 44 degrees will cancel. We'll now have y by itself. And you can find out what it approximately equals to by going 10.2 divided by cos of 44. So to the nearest tenth, that will be 14.2. And that will be in feet because the adjacent side is in feet. These are all done the same way. Start by labeling the sides of your triangle. Look and see what side you're given, what side you're trying to find. Group them together. That'll tell you what ratio you need to use, depending on which two sides you're using. Write your equation, cross multiply, and then you get the variable by itself. Same step every time. In this case, though, there's one extra step to get the variable by itself. All right, so looking at the next one. If we label the sides of the triangle, the side across from the right angle is the hypotenuse. Because you're given this angle of 46 degrees, that's what you're going to use. The side across from that is the opposite. The third side is the adjacent side. In this case here, we're going to use the adjacent and the opposite. We're given the opposite, we're trying to find the adjacent. We're not given the hypotenuse, we're not asked to find it. We're not going to use it. So Jan, which ratio uses adjacent and opposite? That's right. The tangent uses opposite and adjacent. The tangent of the angle, which is 46 degrees. And again, you got to make sure you have the ratio in the right order. On the formula sheet, it tells us that tangent is opposite over adjacent. 10.45 on top over x on the bottom. We make the left side a fraction by putting it over 1, and then we cross multiply. And again, I always start with the pair that has the variable in it. So it's x times tan 46 equals 10.45. What do we do now, Brooklyn Lorenz? Right, we got to get x by itself by dividing both sides by tan of 46. When we cross multiplied here, the variable x was on the bottom, not the top. So therefore, we've got this one extra step to do to get x by itself. So to the calculator we go. 10.45 divided by the tan of 46. And if we round that to the nearest tenth, it'll be approximately 10.1. And that'll be in centimeters because the opposite side was in centimeters as well. All right? So we talked yesterday that sometimes you'll use trig ratios to find missing sides. In other cases, you use them to find missing angles. So that's what this next one will be about, is using the trig ratios to get a missing angle. But we start the same way. We label the sides of the triangle. The side across from the right angle is the hypotenuse. That never changes. Because you want to find angle S, that's where your question mark is. That means the side across from that is the opposite. We're not given it, but we want to find it. So we're going to use angle S in our equation. The side across from that's the opposite. The third side is the adjacent. And in this case, you're given both the adjacent and the hypotenuse. We're not given the opposite, not asked to find it. We're asked to find angle S. So we need to use the adjacent and the hypotenuse, which the cosine ratio uses. The cosine of the angle, which in this case is S, equals, and again the order matters, it's adjacent over hypotenuse. 103.5 over 185.7. So, to find out what angle S is, we did questions like this yesterday, where you're told what the sine, cos, or tan was as a decimal, and you wanted to find the angle. That's where you use the inverse function, cos to the negative 1 of 103.5 over 185.7. So you're going to put that in the calculator. Second function, cos of 103.5 divided by 185.7. And angle S equals 56 degrees to the nearest degree. Remember we talked yesterday that the sine and cosine of every angle is a decimal between 0 and 1, which is true in this case because the top, 103.5, is smaller than the bottom, 185.7. It's a decimal between 0 and 1. If you reverse those, if you put the 185.7 on top, and you try to do this, if you reversed them, which would be wrong, and you tried to do it, your calculator actually gives you an error. Because when you reverse these, you're saying that the decimal is greater than 1. If you put the 185 on top and the 103 in the bottom, that'll be a decimal greater than 1. It won't work because the sine and cosine of every angle will always be a decimal between 0 and 1. Always. Okay? Question B. We want to find the measure of angle B. That's where the question mark is. We start by labeling the sides, though. Side across from right angle is the hypotenuse. We want to find angle B. The side across from that is the opposite. The third side is the adjacent side. So in this case, we're given the opposite and the adjacent. Peyton, what ratio uses opposite and adjacent? Tangent, that's right. So the tangent of the angle, which is angle B, equals. What will the rest of us look like, Allie? What will the rest of this look like? Tan of B equals what? What will go on the other side? Over, yeah, they're the same value, which is 1, right? The tan of B, you could also say then just equals 1. So to find out what angle B is, we've got to go inverse tan. Tan to the negative 1 of 1. Second function tangent. Second function tangent of 1. B is exactly 45 degrees. We don't even have to round this one. It's exactly 45 degrees. Because the tan of 45 is exactly 1. So if the tan of an angle equals 1 and you work backwards, you get an angle of 45 degrees. Remember we said that the tangent can be a value greater than 1. It can also equal 1. It's only sine and cos that are restricted to be between 0 and 1. So for question C, see if you can set that up. Label the sides of the triangle. Figure out which two sides you're going to use. That'll tell you what ratio you need. Write your equation. So do that on your own and then we'll check it. So you should have had the sides labeled that way. Side across from right angle is the hypotenuse. You want to find angle E, that's where the question mark is. So side across from that's the opposite. The third side is the adjacent. Is that what you did, Declan? So what ratio do we need to use here? Huh? Sine. Only sine uses opposite and hypotenuse. So now we write our equation. The sine of angle E equals, and again, the order matters here. It has to be opposite on top and hypotenuse on the bottom. Because the bottom is bigger than the top, that's going to give you a decimal between 0 and 1. If you flip them over, then the top will be bigger than the bottom, and that'll give you a decimal greater than 1. You'll get an error if you proceeded with those two numbers reversed. So to find angle E again, it'll be second function sine. Sine to the negative 1 of 0.45 over 0.63. So second sine, 0.45 divided by 0.63. 63. So if we rounded that, it'd be approximately 46 degrees. Normally we round sides to the nearest tenth and angles to the nearest angle. All right, try question D on your own. So you should have had the triangle labeled like that. The adjacent side is 8.6. The opposite side is 4.5. You want to find angle A. So the side across from that angle is the opposite. The hypotenuse is always across from the right angle. That never changes. So in this case here, we need to use the opposite and the adjacent. Those are the two sides we're given. We're not given the hypotenuse, not asked to find it. Not going to use it. So Sal, what ratio uses opposite and adjacent? Flip back page 2 and you'll see the ratios there. At the start of today's lesson, top of page 7, I think, the three ratios are written. What ratio uses opposite and adjacent? Tangent. So the tangent of the angle, angle A, equals what, Cheney? What will the rest of that look like? Is she right, Keen? Okay, because tangent is opposite over adjacent, right? The formula sheet tells us that. So to find angle A, we have to go second function tan. We have to do tan to the negative 1 of 4.5 over 8.6. So second function tan of 4.5 over 8.6. So to the nearest degree, we would say 28 degrees if we round to the nearest degree. Okay? So we're going to spend a couple more days looking at using our trig ratios to find missing sides, missing angles. We'll get into some problems doing the same thing. So again, on Friday will be a quiz on this chapter. Our unit exam was the following Tuesday. And then we'll be reviewing for your final exam. And again, your final exam will be Monday, June 19th at 8:30 a.m. here in this room. Okay? And that'll be a different day that the other 10 Cs are writing on. So I'll be sending out lots of emails to remind you and your parents of that date. Also next Friday, June 9th, last day to hand in any missed assignments. After that, they go in as 0. Remember that Chapter 2 assignment has to be handed in. Some of you already have, and I've marked them. On the next page, there's an assignment there. This will be due for marks. Okay, so there's this page and the next page, so back to back. Don't forget to put your name on the top. Rip it out, do it, hand it in. Counts for marks. Okay?